Hi, my name is G. Prasad. I and my friends Fanis Sunil, Satish and Nadim combined in this project. The title of our project is Moving Object Detection on GPU using CUDA. Our project finds its application in video surveillance system. The three steps involved in our project are background subtraction technique, morphological operations, and connected component labeling. Overview: video surveillance system, background subtraction, Gaussian mixtures model, morphological operation, CCL, CUDA, GPU. Video surveillance system. It is an automated surveillance system attempts to detect, recognize, and track objects of interest from video obtained by cameras along with information from other sensors installed in the monitored area. The aim of an automated visual surveillance system is to automatically take appropriate action like alerting a human supervisor based on the perceived description. It is an effective tool to prevent security problems. This is the main step involved in the video processing system. There are N cameras attached to video processing. These N cameras sends video signal to the video processing as its input. Background modeling, object segmentation, object tracking, behavior, and activity analysis are the four steps in video processing. If any abnormal situations occur, then alarm attached to video processing alerts the security personnel. What is CUDA? CUDA stands for Compute Unified Device Architecture. It is the world's first C compiler for GPU. The computational part of an application runs on GPU while the controlling part runs on the CPU. CPU is good for controlling data caching while GPU with 200 cores is excellent in calculation. Terminology: there are three terms used in our project: device, host, and kernel. Device stands for GPU, host stands for CPU, and kernel stands for function. Example of CUDA processing flow: first of all, the data from main memory is copied to GPU memory. Then CPU instructs the process to GPU. GPU execute this process in parallel in each core, and the result is copied back to the main memory. Modern GPUs contains hundreds of arithmetic units. Most of the transistors in CPU are dedicated for data caching and controlling. Serial programmer. In serial programmer, the single thread is attached to the ALU. In parallel programming, multiple threads are run simultaneously. CUDA. Since CUDA is a parallel programming, it launches thousands of threads simultaneously on GPU. CUDA device memory allocation. Let us first of all discuss how memory is allocated in device memory. CUDA malloc function allocates objects in device global memory. It requires two pointers: address of a pointer to the allocated object and size of the allocated object. In order to free this object, CUDA free function is used. Data transfer. How data is transferred between device and host. CUDA memcopy is the function that is responsible for data transfer. It requires four parameters: pointer to destination, pointer to source, number of bytes copied, and type of transfer. There are three types of data transfer: host to device, device to host, and device to device. Background subtraction technique. This is the first step of our project. Background modeling is a technique for motion segmentation in static scenes, that is subtraction of current image from the reference background image. In order to detect whether a pixel belongs to foreground or background process, the Gaussian distributions of mixture model for that pixel are evaluated. This is how a background subtraction is done. If the previous frame and the current frame and the background image, the current frame minus previous frame gives the foreground image. Gaussian mixture model. A Gaussian mixture model is parametric probability density function represented as a weighted sum of Gaussian component densities, used in biometric systems such as image tracked related special features in an image recognition system. The number of modes in arbitrary predefined, usually from 3 to 5. Morphological operation. The image obtained from the background subtraction contains noise. In order to remove that noise, we apply morphological operation. Morphological operation contains two types. There are dilation and erasure. Morphological operations apply a structuring element to an input image, creating an output image of same size. Applied in removing noisy foreground pixels that do not correspond to actual foreground regions, and to remove the noisy background pixels near and inside the object regions that are actually foreground pixels. Erosion operation. As the name itself, it implies erodes 1 unit thick boundary pixels of foreground images. The number of pixels removed from the object in an image depends on the size and shape of the structuring element used to process the image. What is structuring element? A structuring element is a matrix contains of only zeros and ones that can have any arbitrary shape and size. The pixel with values of 1 define the neighborhood. Dilation. Dilation adds pixels to the boundaries of object in an image, while erosion removes pixels on the object boundaries. This is an actual image. The actual image after background subtraction gives the foreground image with noise. In order to remove the noise, we apply morphological operations. After morphological operation, the noise of the foreground image is removed. Connected component labeling. It is the last step of our project. In this, connected component regions are found by using a connected component labeling algorithm, and objects bounding rectangles are calculated. Connected component labeling works by scanning an image pixel by pixel from top to bottom and left to right in order to identify connected pixel regions, that is, region of adjacent pixels which share the same set of intensity values for binary images v equal to 1. In this, the 4 connectivity is applied. Coming to our project video consists of 4 frames. In this 4 frame, the first frame corresponds to the input frame, the second frame after background subtraction, and the third frame after morphological operations, and the fourth frame the final output after CCL, connected component labeling. This is our project video. These 4 frames run simultaneously at this video is done using MATLAB. CUDA applications: engineering simulations, electronic design automation, information security, oil and gas, manufacturing, video editing, finance, and fluid dynamics. Thank you.